Dichlorodiphenyldychloroethylene, also known as DDE, has a molecular formula of 14 carbon, 8 hydrogen, and 4 chlorine. DDE is a primary metabolite from dichlorodiphenyltrichloroethane, also called DDT, with a molecular formula of 14 carbon, 9 hydrogen, and 5 chlorine. So what is DDT? DDT was the first synthetic insecticide introduced in the 1940s and was widely used to fight typhus, malaria, and other insect-borne diseases in the human population, including to protect crops, livestock production, and households from insect infestation. It wasn't until the late 1960s that evidence supported the environmental and toxicological effects affecting wildlife. Officially in 1972, the Environmental Protection Agency counseled the use of DDT in the US. Other countries have also discontinued the use of DDT, but an exception supported by the World Health Organization is the indoor use in African countries where malaria remains a big health issue. DDE is known as an organochlorine pesticide because it is a part of the chlorinated hydrocarbon derivative group, meaning it is a chemical that was used in huge amounts around the world, referring to DDT. The pharmacokinetics, which is how the toxin enters and moves within the body, is by directly swallowing, absorption and contact with skin, or inhalation. Pharmacodynamics is the effects of the toxin within the body. At this time, there is record of animals being affected by DDT that cause tumors. Therefore, it holds a cancer classification of group B2 to possibly cause human carcinogen. DDT may also cause liver and kidney damage, but depends on exposure levels. There is inconclusive information of the short and long-term effects of DDE by itself. Since DDT was a resourceful insecticide to fight diseases and protect crops, it was used for 30+ years. It is very persistent in the environment and still lingers today. As said before, it has affected animals and has the potential to cause human carcinogen. Specifically, DDE has no commercial use and is only a harmful primary metabolite from DDT that enters the air, water, and soil. As long as DDT remains in the environment, DDE is present. Solely, it is not a natural occurrence in the environment. Exposure levels in the US are based on case-by-case interactions since DDT has not been used in almost 5 decades. Although DDE is absorbed strongly in surface soils and can seep into groundwater, rivers, and lakes. Therefore, sources of exposure can be through contaminated food due to contaminated soil, where plants are directly affected and then eaten by animals that we may consume. DDE exposure can be through inhalation or skin absorption and can be detected in fatty tissues, blood, urine, semen, and breast milk. DDT and DDE can be transferred to fetus or infant through fatty tissue storage and breast milk. According to a study to measure DDT and DDE levels in the US, CDC scientists had 1,956 participants aged 12 years and older during 2003 and 2004. The results of blood samples concluded that a small portion had DDT, but most had higher detectable amounts of DDE since it stays in the body longer. With DDE present, It represents past exposure. These results show how DDT remains in the environment and is in all of us. But it is 10 times lower than earlier studies conducted in the 1970s. This does not mean it still causes poor health effects, only that it is present and levels are expected to continue dropping. Lastly, for workers, according to the Occupational Safety and Health Administration, or OSHA, workers may not be exposed to amounts of DDT greater than 1 milligram per cubic meter of air for an 8-hour workday or 40-hour work week as a precaution. Today, federal regulations still monitor amounts of DDT in food and water. For DDE, according to the Environmental Protection Agency, it has made the determination not to regulate DDE with a national primary drinking water regulation, because DDE appears to occur infrequently at levels of concern in public water systems. The agency believes that a national primary drinking water regulation does not present a meaningful opportunity for health risk reduction. The ambient water data from the United States Geological Survey indicates that the maximum concentrations detected in surface and groundwater were less than the health reference level.